All right, for this video, I'm going to show you how to do the math for this particular lab. If you did not do this lab in class, there is a video that you should watch of 2 students performing the lab, and their results are featured at the end of the video. There's a table where they wrote their results. The table looks like this, and you are going to copy their results on your paper, okay? Also, please answer the questions at the beginning of this lab. The answers can be found in lesson 2 of this particular unit. So that can be done at any time. All right, so I want to show you how to do the calculations for the first food sample, which is the walnut. We're going to do this one together. It won't count for marks because we're going to do it together. And you are going to do your own calculations for the marshmallow and Dorito food samples the exact same way we're doing for the walnut, but you're going to have different numbers, obviously. So let's just begin with that. I will go to PowerPoint. So first things first, can you write down on your table in your lab the average of the class here? Just add this on one of the sides in your lab report. What happened in this lab was that 5 groups did the actual lab, and some got great results and some got horrible results, which is totally fine. But let's pretend it's kind of like you ran the lab 5 times. So we're going to take everybody's data. We're going to average out the grams that was burnt for each of the food items. So just copy these averages down. You're going to need those. I'm going to flip ahead a lot. And if you ever just need to pause the video, that's what you should do, because I'm going to just keep going, okay? On the second page of your lab, you will see these calculations and these pictures of the nutrition facts for the 3 foods we were using. You're going to need to refer to this for the questions. So let's do the walnut example together. If you want to number these little points here, go ahead. It's kind of like having 5 separate questions. So let's tackle each one of them separately. I've got like 5 slides, but you have like a large area and space on your paper. So for number 1, sorry, this is going to get pretty sloppy with using my iPad to draw this. It says calculate the change in thermal heat in joules. So you're going to be doing the mathematical equation of Q equals mc delta T. Right, if you remember from the lab, we used 50 milliliters of water to add to the pop can, and that was the water we were measuring, the temperature before and after when we were burning the 3 samples of food. So you can actually use that volume for the mass in this question. And so the mass of the water is actually the same as the milliliters you used. It's 50 milliliters, so it's 50 grams. So our M for this question is 50 grams. So we're just going to put 50. If you remember the specific heat of water, that would be the value for C. It's 4.18. And you don't need to write the units here just because we're just going to be calculating like the whole thing. Delta T is coming from the table here. So I don't have the numbers filled in, but I'm using the results from the 2 students in the video. And their results were, hold on here. The final for them was 24 degrees minus the initial, which was 21. So when you do this calculation, you get 627.6 joules. That is what this question is asking. So calculating the thermal heat in joules. This one's done. All right, on to the next one, which is now we're going to do number 2. So it's saying convert your answer from joules to calories. Whenever you hear the word or see the word convert, use the strategy that I've taught you with the picket fence, okay? So we are going to write down our answer from this slide, from this question, 627.6 joules. Draw your picket fence. Now you know you're going to need a joules down here because you're going to want to cancel those out. And the question is asking for joules to calories. Calories with a lowercase c is equivalent to chemical calories, not food calories, which we'll get to in a second. So chemical calories. Now, where are you getting the numbers for this conversion? If you go back to your lab report and you look at page 2, you will see this conversion right here. 1 chemical calorie is equivalent to 4.184 joules. So let's go back to that slide and we're going to put that in. So 1 chemical calorie is equivalent to 4.184 joules. And this is a division. So once you do that on your calculator, you get 150 calories, lowercase c, chemical calories. So now this one's done. Let's go on to the next. Number 3. It says convert the answer from calories to calories. So it's from chemical calories to food calories, capital C. So what do we have from the previous slide? 150 chemical calories. I don't want you writing chemical calories, food calories. I just want you to know that lowercase c is for chemical calories, capital C is for food calories. So 150 lowercase c calories. We know that with a picket fence, you're going to want to have that unit down here so we can cancel them out. How do we know this? Go back to that slide, and now we're looking at this one. So 1,000 chemical calories is 1 food calorie. All right, let's go do that. All right, and when you do that division, because 150 times 1 is just 150, divide by 1,000, you get 0.15 calories. We still got a couple steps to do, so hopefully you have room on your paper. We are now at question 4. So this is got a little bit of a step, okay? It's just going to tell you, compare your answers in food calories to the same number that's listed in the nutrition facts. So we're trying to see here what should be the answer you're getting and what was the answer you got from your lab. So we're going to be using now the mass here. So we're looking at the walnut. The average for the class was 0.08 grams. But first we're going to just look at the nutrition facts. I'm going to start with this one. So this is the walnut facts right from the package. And if you look here, 30 grams gives you 220 calories. So let's go back to our slide and just do a quick calculation. We're going to do 220 calories divided by 30 grams. This is from the label, okay? This is the store, the company, whatever, not the store. When you do that division, you get 7.3 calories per gram. So if you ate 1 gram of those walnuts from that package, you would be consuming 7.3 calories. It would give you energy equivalent to 7.3 food calories. Let's do the calculation for the lab. So we will need capital C, our answer for calories, which is on this one, number 3. We had 0.15, so let's just go back and write that. 0.15 calories, food calories. And our mass, this is a mass on the bottom of this equation here. And so our mass is going to be right here from what we get with the class average, 0.08 grams. So let's go put that in, 0.08 grams. And you get an answer of 1.88 calories per gram. And this is coming from our lab, okay? So when you look at these two numbers, what a difference. Okay, this is what we should have gotten, but this is what we got. And that's okay. That's totally fine. This lab is not perfect, so we're going to calculate our percent error, which is the last question, number 5. It's asking you, was your calculation close to the nutrition facts label? You can just put out a flat out no here. But I don't want you to stop there. I want you to give me the percent error. We did this in grade 11 chemistry. I really want you to know this equation by heart at this point. So a percent error is going to be absolute value of the experimental value. I'm gonna run out of room. Minus the actual absolute value divided by the actual. Don't forget when you're doing a percent, I'm out of room here a little bit, but it's times 100. That's a terrible times 100. That should be like beside this whole thing, okay? All right. So what was our experimental value? Well, it's 1.88. So let's put that in, 1.88 minus the actual, which is what we should have gotten, 7.3. If you put the absolute here, it's going to make that negative turn into a positive. The actual goes on the bottom again. This is where I can properly write this times 100. And it's going to give you a percentage, which is 74%. A horrible percent error, very high. You want to have a lab, you can feel safe knowing your lab went really well if your percent error is under 10%. So I totally expected these values because, I mean, we're using a little aluminum plate. We're burning a piece of food. It's not burning well. We've got a pop can with water. It's warming up, but it's really not perfect. The heat is escaping to the surroundings, the atmosphere. The energy's not completely going into the water. So it's a flawed lab, but I still wanted you to go through the process anyway. So that's how you do these questions. I would like for you to do the same for the marshmallow and Dorito using that process. But remember, you will be using the values that are in your table for temperature, and don't forget to use the class average for these other two for when you need the mass, okay?